will be a little bit different than our regular classes. I'm not, we're probably gonna learn more from the industry and what he does on his daily things and how he's able to get where he is. He'll probably have a lot more insight on that part than I have, and just gonna give a probably 5-10 minutes just to see if anyone has any other questions. Oh, maybe we can try sending questions or try using the chat. That way we'll know that it's working. So if anyone can send a message just saying hi, or that way we'll see if we can see it. Let me try the Remind app. Oh, I got some messages.
So good morning, everybody. Like I said, I'm Nicolas Costilla, the guy that was invited here to talk a little bit. Before we wait for everybody to join in, I just wanted to get a quick heads up. For me, this is going to be super informal, so don't expect me to be super proper, I guess. Yeah, so look forward to talking to y'all. But yeah, it'll be super relaxed. So just a heads up.
So someone, I guess we're gonna answer this question once everybody is in, but they're asking what does exactly a quality engineer do?
All right. Yeah, just let me know whenever you want me to start explaining.
Okay, I wanted to show them, I guess we're gonna wait until like 12:07, maybe 12:10. And then I wanna show them a couple of videos. Just kind of like, I don't know, well, I don't think they have seen the Toyota plan, but I just wanted to share that they have open tours for everyone. You kind of like, I think I sent you the link. You can go in their website and sign in a day and a time. Right now, of course, of the situation, I don't know when they're gonna be open them again, but probably in the next years or in the next few months, hopefully, I don't know. But they were having those tours open for public, for students, and you can register as a group or by one person, and they have like a little museum and they'll show you all their processes. I think there are a couple that you cannot see, like painting and another one that I don't remember, but they have like a demo that you will be able to see how they do all their manufacture from assembling all the parts to getting the truck ready out of the shop. So I see some people that are just joining in. So I'm just gonna give like another 2 more minutes and we're gonna start. Nick, are you planning on telling a little bit of your background too?
Only if you want me to.
Yeah, that would be cool. I haven't got any more issues, questions, or logging in, so I just give you like 1 minute and then we'll start. I'm gonna start. Okay, I hope you guys are doing good and we're ready to start. Let me start sharing my screen. Share screen. Are you guys able to see my screen?
Yes.
Okay, good.
Now, San Antonio would be a place I call home. A place where anything could happen. You live here in San Antonio, Texas, and you work at Toyota, drive a Toyota Tundra. My name is Rick Cunningham. I've helped build close to 700,000 Toyota Tundras. Now, this plant here has brought in 6,000 jobs.
My kids at a very young age took a lot of pride in the fact that their daddy works for Toyota and he builds vehicles.
So much pride, so much dedication goes into building these trucks. A sense of accomplishment. I know what we're building because my hands are on that truck. I know the quality and the effort that goes into building our Toyota Tundras. From the beginning, from just a sheet of metal, all the way to the final process, where it's driving off. You know, it's revving that engine and you hear it, get those goosebumps.
You have something your process is good enough. The belief system is it can always be better.
Kaizen is continuous improvement, right? Kaizen is all around our shop. How do we go the extra mile? The blood, sweat, and tears that goes into making all of our Toyota Tundras. I love it because it is American made, Texas built.
People want a Texas built truck, and we're the only ones that can deliver that.
We're driving the best quality truck around town.
Texas made, Texas proud, right? Yes.
Toyota is a big name here in San Antonio. This is my home. This is where I plan to stay.
When they see a Tundra driving down the road and my little 11-year-old asks, Dad, did you build that? And I say, yes, I did.
Awesome.
That's one, and I have another one. This one's more about the system that they do. Nice, very cool, right? Let me admit one more. So, Don, Nick, your turn.
All right. So I guess going off of what was presented in that last video, the Toyota production system is kind of what we're most famous for, just because there's a strong emphasis on quality. And I don't know how much you guys looked into Toyota, but it's a Japanese company that manufactures Tundras trucks in Texas. So a lot of our ways of thinking are kind of based from Japan. So they had mentioned the word in that video kaizen, which is, like you said, continuous improvement. So really, there's every single thing that is done on that vehicle. It's seen as a process. Shooting this screw bolt or whatever. Everything is a process, and it's been broken down that way and standardized so that way you can say, okay, it's taken 5 to 10 seconds to shoot this bolt. If we find a way to reduce it from 5 to 10 seconds to even 3 to 8 seconds, that's 2 seconds reduced per vehicle, and then do that for the entire production of the Toyota Tundra for the entire year. You end up saving a couple of seconds multiplied by, say, a couple 10,000, 20,000, and basically it all equates to saving time, which equates to saving money, which equates to profits. And then also reducing burden on the assembly workers and whatnot. Because really, the other thing that was not mentioned in the video is that one of the core pillars of Toyota is kind of respect for people. So they had mentioned that everybody within the plant has the ability, and they're encouraged to look for ways to improve processes, make things more efficient, or if they see something wrong, you raise your hand, you say, hey, this looks like a problem. And you really, everybody believes that. It's like, if there's a problem, it's much better to raise attention to it now and fix it. So, let's see, what else? I guess before I go on, I'll answer that one question. It's like, what exactly does a quality engineer do? So, like I said, I'm a quality engineer. I know Monica had said Toyota expert. Wow, I'm flattered. I've really only been working there for about 2 years, so I mean, I'm well versed in the Toyota production system, but expert, yeah, flattered me, but that's fine. Anyway, so what a QE does is really, it's almost like a stopgap for anything that goes wrong. It needs to be fixed. When somebody raises their attention and say that there's a problem, usually a quality engineer is sent to that problem. So, like we said, if there was a problem with, say the bumper can't be installed, the front bumper can't be installed, somebody on the production line raises a flag. It's like, hey, we're having this problem. We're seeing this problem. So a QE, well, quality engineer will go scope out the issue, offline that truck, and then they start their investigative process. So it's like, okay, how many parts go into this bumper? What does this bumper go to? What suppliers are responsible for which parts? And then you start seeing, okay, what is the standard condition that this bumper is supposed to be in? What is the condition that we're at currently? And it's kind of like, Sherlock Holmes, but with vehicle parts. So really, being a QE at Toyota, it's kind of broken down into two roles. There is a mass production QE, which kind of functions exactly like I was telling you right now, where engineers call to a problem and then they kind of begin their investigative process to find what the root cause of the problem is, find a solution for that problem, and then begin in developing a countermeasure to make sure that problem doesn't happen ever again. So that's the mass production side. They're really the firefighters of the manufacturing, or our manufacturing. It's like there's a problem, they figure out what's wrong and they fix it. The other side is that I know you guys realize that every year there's another vehicle that comes out. It's just a different iteration of the Tundra. 2017, 2018, 2019, 2020, 2021, so on and so forth. So every time that something is added to that vehicle, there is a lot of kind of pre-production stuff that's involved with that. Now, primarily at the plant, we're not responsible for the design of the vehicle. There is a group in Michigan, or sometimes in Japan, that they're responsible for designing the vehicle. But the thing is, designers are not always in touch with what the real condition of manufacturing is at our plant. So what happens is a individual designer suggests a certain change to the vehicle for the next model year that's coming up. Now there's engineers like me. This is kind of what I do. Like say, hey, we want to do this. We want to change this part, or we want to add this component. Blah blah blah. What problems will come from that? Now, what I would have to do is I would look at the part that they're proposing or look for the change they're proposing and figure out, okay, what will this do to affect the overall quality of the vehicle? If they add this, will this part no longer fit? Will it, end up having a terrible appearance when you do install it? Is the supplier even capable of, accurately manufacturing this part? So it's like a whole lot of, you know, not deductive, but it's kind of like product development, but with an emphasis on quality. So that's the QE pilot program, I guess, where it's helping the designers not not implement something that will be detrimental to the overall quality of the vehicle. So that's the main focus for the QE pilot program. So in short, not even short.
Did
That's
they do testing?
yeah, that's part of the whole cycle. I can try to go over it as fast as I can, but really there's multiple phases. It starts off with the concept, bare bones concept. Hey, designer, this is kind of what we're trying to address, and then it kind of starts getting some meat on the bones of the concept, where it starts formulating, and then once they get the final design, and then you end up to the point where all these parts you need tooling for it. If it's a plastic, injection molded part, you have to get, a giant tool block of steel and then machine it and blah, blah, blah. So there's a whole timeline for that, ordering tool steel, machining the steel, and then suppliers have to have trial runs. There's T0 where it's just like, the first like quick run of, injection molded parts. And then there's the next trial where it's supposed to be kind of checked. So like, it's kind of like an iterative process. At T0, there's low expectations for overall quality, but you hope they to be dimensionally accurate, and then so on and so forth. You kind of refine it to what we have. We have kind of standards for what the part is supposed to meet, dimensional, and then there's also kind of environmental criteria. There's also, depending on if it's like a chrome plated part, they have certain, well, there's appearance, have to match a certain appearance, but then there's also criteria for, rock chipping and whatnot. There's a whole list of standards and tests that need to be done for all these parts. And the QE pilot engineer is responsible for making sure that these tests are performed, make sure they satisfy the criteria that is specified by Toyota standards. And then if they're not meeting standards, then you have to work directly with your supplier to figure out how to make sure that we're meeting standards, and then kind of so on and so forth. So it's kind of like a huge countermeasure cycle, but it's, it's, excuse me.
So right now I am like showing them how statistics is very important. Like so I'm kind of like showing them how we have a population, and then we have a sample, and then we start getting like oral or data, and then we kind of like be able to see trends or be able to check like the mean, or we have an outlier. Do you apply those concepts like on your daily basis or no?
For the QE pilot program, not on a daily basis. What I would have to do is say, okay, if I see that there has been a problem historically, then I would look up to see, okay, what is all this data? Pretty much data is king. So I would have to go and accumulate data. For the mass production engineers, for them, it is a definitely everyday process. So like I was saying, if the bumper can't fit, what they would really have to do is that we have certain documents that apply to every single part. So let's say there's a piece of sheet metal that has a hole, and you have a different kind of metal peg that's supposed to fit into that hole. Now there's a whole bunch of, I guess, data that the supplier is supposed to be keeping track of for the diameter of that hole and the position of that hole. Now they keep that data, and it's sent to us in a form of kind of like a control chart, kind of like X bar R chart. And that contains, okay, what is the target? How are we varying? And then it shows us how in control their process is, or you know, if we have a couple of outliers that are outliers, or in our case, are non-conforming parts. So it kind of helps us understand what the capability of the supplier is and when they get out of control. So that is mainly for for the mass production engineers. But yeah, every single dimension that is on a part has some sort of data correlated to it. And if there is a problem that ever arises, the mass production engineer will have to look at these different charts, which is, you know, accumulated from the supplier data. Sometimes it's not always variable data. Sometimes it's go, no go, like does this fit? Yes, cool. But typically those charts and histograms are based off of the, you know, numerical data that we get from the suppliers.
Cool, thank you.
Mm-hmm. Yeah, so I guess the only other thing that I would talk about is a little bit more, you guys have gone over Six Sigma, correct?
What?
So you guys have gone over Six Sigma?
A little bit, not completely yet.
Okay, all right, maybe I'll just omit that part.
Wow, that's very important.
It is, but I mean, it kind of plays into the whole sample mean and variance conversation. So really what we do is
you can explain why Toyota it's the leader, or why it's known for Six Sigma, or what do they mean by Six Sigma? How they use Six Sigma?
Okay, so Sigma is kind of a, I don't want to say ideology, but it's basically using stats to predict, I guess, the outcome of certain parts. So say if your process is, you know, Six Sigma, that means 99.7% of your parts will be accurate or on target within your upper and lower, sorry, I was looking at my phone, upper and lower spec limits. So
right.
Actually, are you able to share your screen? Could you possibly pull up a little something?
Yeah.
So basically, you would expect 99.7% of parts to be accurate. But the main thing to remember is that Six Sigma, that kind of accuracy and I guess performance is actually not common. Like a lot of people, you shoot for Six Sigma, but you don't always get Six Sigma. So the thing to remember is that, okay, 99.7% of your parts will be accurate. There's always that 0.3% of parts that even if you're running absolutely perfectly, 0.3% of your parts will not be in spec. So I guess this is actually the main thing that I would like to explain to y'all, is that nothing is ever perfect. Nothing is ever perfect.
Do you want me to put one of these images, or the chart?
Preferably the chart, that one right there, yes.
So this is kind of like a histogram that we were talking, that we have a range, and we have our upper class limit and our lower class limit.
Correct. So you can see right there, your mean, typically for us, our mean is always our target dimension. It's our nominal dimension for, say, a hole. If our hole is 8 millimeters, right there, mean, our expected target is 8 millimeters. Now what we look at is like, okay, for a hole to be within spec, we would try to be within 1 sigma to make sure that all the other parts that made around it are kind of okay. So we would expect, you know, 8 mils plus or minus 1.5 mils. But I guess the main thing that I'm trying to, I guess, emphasize is that, say, if we're running at 6 sigma, which is, you know, we would expect all our parts to be within -3 sigma to +3 sigma, there's still a little upper band. You can see it between 3 to 4 sigma that would be technically out of spec. Now, if you were to look at this as a process of, you know, a bunch of processes in series, that's essentially a 0.3% chance of failure. Now you multiply that by, you know, however many components you have in a process, you can kind of start to see that overall there is a lot of, well, expected not in spec components in any manufactured process or component. So really what I'm doing in the QE pilot program, I guess, is you need to design certain things for Six Sigma. So let's say, going back to that whole example, I'm trying to design a part to mate into a hole that's 8 mils plus or minus 1.5. Now, if the supplier's capability is not even near three sigma or Six Sigma, then we need to make sure that we have either enough slop on that hole. I guess slop is like kind of extra space to go about it. So ideally, we would have 8 mils plus or minus 1.5, but if we can design it where it's still acceptable and functional with 8 mils plus or minus 3 mils, we essentially doubled the tolerance that the supplier can use, meaning that even if they're not up to par with Six Sigma, that we'll still have usable parts. So that's really what my main focus of my job is that we help the designers and suppliers uh, set themselves up for success, I guess, which sets us up for success. It's like if we can design a component that the supplier can easily make repeatedly and accurately, then when it comes to assembly, we'll have a lot less issues and overall higher quality vehicle.
Yep.
So, yep, that's the gist of it, really.
Makes sense. So I would like, do you want me to pull another image or no?
No, I mean, I feel like I've kind of touched very high level on what we do at the plant and what I do. So at this point, I mean, if there's
Let's
any,
see if they have any other questions,
yeah,
they can send them. And I would love to hear your story.
my story. What story?
Yeah, I mean, like, what did you study? Where are you from?
Oh, okay. So I'm from a very small town, down South Texas, Carrizo Springs, Texas. Um, Population of 5,000 people. Um, my parents were not engineers. My dad was actually a school teacher, but unfortunately, I was very good at math, science, physics, and whatnot. So it was like, hey, why don't you be an engineer? Um, so I ended up studying here, San Antonio, UTSA, mechanical engineering. Graduated fairly recently, was it like 2014? Since then, I've been kind of working in different industries because really what I wanted to do when I started was be a design engineer. But then speaking with design engineers, I mean, they're all right, but they're kind of out of touch with what the real world is. Usually design engineers, they have an idea of a perfect design, but they don't really know what goes into making that design possible. So I ended up started working as a quality engineer for, I'm not sure if y'all are familiar with Pratt and Whitney. They kind of do turbines. It's like aerospace stuff. So it was really just checking documents, making sure that our part suppliers are adhering to what was supposed to be made for the different aerospace components and whatnot. And then I ended up working at James Avery because I still had my design and production engineer ambitions, and this is how me and Miss Elbjorn ended up becoming friends. Then after that, I realized I was much better at quality just because when you're working with product development, you work with artistic people that don't really see how things are actually supposed to be made. And there's kind of that dissonance in my mind where I understand that they want to adhere to their vision, but then there's always the real world. The real world's kind of more important. It's like if you have a perfect idea, but it can't be made, then what's the point? So I ended up getting a job offer at Toyota. So started working at Toyota and I've been working on, working on the new vehicles that are coming out year after year. And yeah, that's that quick story.
Cool. Very cool. Anything that you would like to add to this prep students? I just want to thank you so much for your time. I know it's a holiday and probably you're having big plans.
Yeah, just waiting for my wife to get back from grocery shopping so we can have a barbecue. But
That's cool.
yeah, no problem. I kind of apologize. I wish I had taken more time to prepare, but work's been kind of busy, just
No,
trying
and
to get stuff
and
wrapped up before the holiday.
I do understand also that a lot of things they're kept as a secret.
Oh yeah, I can't say too much, so just overall high level stuff. Like really, kind of what you were saying earlier, the whole tour of the plant.
Mhm.
I mean, that's much more beneficial than just kind of talking about it, because you can kind of
Yeah.
see all the different processes, and it makes it feel a lot more real.
Yeah. And I will go over with them with the Six Sigma. Nick is a Six Green Belt certified.
Oh yeah, yeah. Six Sigma green belt. I think there's tiers. Lowest tier is yellow belt, then green belt, then black belt, and there's also a
And
master
master
black
black
belt.
belt. Yeah.
Yeah, but I have no intention of getting those just because personally I always enjoyed working with more hands-on stuff on the technical side, and I believe that once you start going for black belt, master black belt, you kind of get towards the managerial level where you just you no longer get to problem solve. You just have to manage schedules and manage people, and that seems a lot less fun to me.
Mhm.
But yeah. So if you guys have any questions, like what would you recommend if you're trying to go in the STEM career, STEM field, or how to best prepare for college or something or whatnot? Just feel free to ask. I think we have like 15 minutes. I don't know how much time we have left.
Yeah. Or we can just let everyone leave early.
That is also a good idea. I mean, everybody can get to their vacation a lot sooner.
Yeah. Well, thank you so much, Nick. Enjoy your weekend. And thank you guys for joining in. And I hope you enjoy listening to Nick as much as I did.
Yeah, he flattered me too much. All right. Yeah, thank you guys for listening, for putting up with my rambling and whatnot. So, all right, I guess that's it.
Okay.
See you guys. Bye.
Bye.